What if you could own a Boston Dynamics style robot dog for a fraction of the price? This is the Unitree Go2. It's an advanced, agile, and relatively affordable robotic dog designed for research, education, and even practical applications like surveillance, exploration, and assistance. It's a $2,000 robotic dog with some pretty nifty tricks up its sleeve. It can pounce, it can run, probably faster than I can, and it's been known to beg to get into the video room. Because let's face it, nobody's gonna trust this thing with a keycard. It can climb stairs, drunkenly, but it can do it. And it can go downstairs even faster. It can even right itself if it tips over. Best of all, it's great at fetching coffee, just don't expect a tip. There are things it's not great at. It doesn't play fetch, it doesn't socialize, and it's not gonna replace your beloved pet companion. It's also not in the same class as the larger industrial robots like Boston Dynamics' Spot. At about 1/50th the price, it doesn't really need to compete with Spot either. In fact, there are no competitors for a similar device at this price point. That's also what makes the Go2 special, the price tag that puts it in the consumer electronics category. Sure, it's unsteady on its feet and it tips over from time to time, but make no mistake, this is cutting-edge robotics at a price point comparable to an RTX 5090, before the scalper's markup. Now this is a whole new product category for us, and to make sure we do things right, I thought we could use a little help. Fortunately, I know a guy. So our CEO Kyle has insisted that this robot goes back together in working order, and to help me out, I've brought along Marcel Stieber, who has over a decade of consumer electronics experience and robotics in particular. Marcel, can you tell us a little bit about this device that we have on the table?
Sure thing. I think what's really exciting here is that we have a consumer accessible robot dog. It's pretty impressive, right? So something under a $2,000 price point that's available to consumers. It's obviously a very different type of product than something like the Boston Dynamics Spot robot. We've probably all seen the videos of the dancing dogs, but that's a multi-tens of thousands dollar device that has really a completely different class, a lot of different capabilities and more industrial commercial applications. What's really impressive is how a product like this has come down to such a low price point, making it consumer accessible. Granted, it doesn't have autonomy, right? It's remote controlled and you're driving around, but it's very capable. It's really impressive how quickly these have developed and how low they've come in their price points.
And it packs a punch too. It's got these spinny LIDARs up front and the motors that go inside these things. You were telling me this was one of the more expensive parts inside the device.
Yeah, so typically for a bot like this, one of the big challenges is getting low-cost actuators for the various different joints. So it's definitely something we want to look into in a little bit more detail inside. But what's really impressive is just looking at how capable these are, right? So one of these legs has over 270 degrees of motion, right, going all the way around. And what's really neat is that it's back drivable as well. So that means that when the robot's not powered up, I'm able to fully navigate these and move these through their range of motion.
Nice. Where would you like to get started? What's our first point of contact here?
I like to start by taking out the battery. This one has a really accessible battery, which makes it handy. And that way we make sure that nothing's energized as we get further down under the skin. So the nice thing about this robot is it's very accessible here on the front. You can move that leg out of the way again, even though it's not powered, and just remove it like that. So it's a pretty simple removal, and we can take a look deeper inside. So inside this case, I'm expecting to see a whole bunch of battery cells and some battery management board that kind of has the pieces all together and yeah, see how accessible it is. All right, so we've removed those battery screws there. Now we have that cover, which has these pogo pin interfaces that interfaces with these and goes to the battery indicator on the top. So that's nice that this is removable, and it looks like those screws are also just Torx, and that might be stuff that you could repair pretty easily too. So that's nice. So then we'll take this guy out, and it looks like that just slides out. So there's just a plastic housing here, so that's quite handy. And then this is our main battery pack. So we've got our main interface here for the robot, our charging port interface, our main conductors here, which are big copper bus bars. We got the main battery management unit across the back, that pogo pin interface to the actual capacity indicator, and then our big array of cells. So here we can see a large array of 18650 cells. So that's 2, 4, 6, 8 by 4. So that's 32 cells inside this pack, which is pretty big, with the date code of 2024 March on it. Okay, so this is the battery management board. We just pulled these 8 screws out, 10 screws. And if we fold this back carefully, we can see here's a lot of the battery management. This is probably all the charging chips because this is the charging port that comes in. And then there's another board in here that's connecting all the cells together. So these are your sense lines going into each of the individual strings of batteries that are nicely labeled here, BT1, BT2, BT3, 4, 5, all the way to 8. And then in here we've got our actual battery management chips, which are these right here, and they've been laser etched off so you don't actually know what the markings are on them.
So that was a fascinating look at the battery, and I'm wondering, what are we going to look at next? We've got the LIDAR, the motors to look at, but there's also a main board under here somewhere.
Yeah, I think let's start off by taking a look under the skin and just see if we can get this top cover off and start seeing how we can take it apart. There are obviously a lot of screws available on the front, but I don't just want to start ripping everything apart. I want to kind of be a little bit methodical and take a closer look at some of these areas. Alrighty, so we got those 6 screws out. One of them didn't come out all the way. And I think we can get this cover off. Look at that. Beautiful. So in my mind here, I mean, the easy one, this is a little fan. So there's a little fan spinning here underneath. This one is our wireless communications board. So it looks like they're using, oh, that's for GPS, it looks like, or GLONASS. So GNSS is marked on that connection point right there. And then this one right here is another antenna. So these are coaxial cables going there. So this is probably the Wi-Fi board, I'm assuming. Looks like there's an Ethernet connection here, which is not user accessible that I know of, but
for troubleshooting? Maybe
for troubleshooting, debug, or accessing it. So that might be interesting to see if there's some availability there. And there's another one of these XT30 connectors here, which looks like it might be another way to power up this board, maybe if the battery's not there. So that's kind of interesting. And then our main processing looks like it's this section right here. This looks kind of similar to some of these development kits you can get, like the NVIDIA Jetson boards. There's a big heat pipe here, so these 2 pieces of copper are going to this copper heatsink as well, and that's probably where all our compute's going on. So I want to be really careful not to touch anything in here unless we ground ourselves first, just to avoid any electrostatic discharge that might break anything, right? So these are a lot of debug ports, fan number 4 and fan number 3 ports as well. Fan number 5 is used. And then all the high power connectors for the motors, it looks like, or the actuators here, right? So that's higher power with a communications port. So if we take these out later, looks like they're glued in, and they have some tape over them as well. Again, this robot's in a shock and vibe environment, right? Shock and vibration, all nonstop. It's bouncing around, it's falling down. So it's really important you don't want these falling out or working their way loose over time, or creating any corrosion inside that may damage the connectors and lead to premature failure as well.
All right, should we take a look at the front sensor assembly? Is that what we're going for?
Yeah, let's see if we can get inside here and start taking some of these apart. So I'm going to carefully remove some of these pieces of cloth tape. So it's really interesting to note there's just a lot of tape all over the place. Really the goal here is, again, high shock and vibe environment. We don't want any of these cables vibrating loose. So if you have a large length of cable that is able to rattle around or bounce around, that will literally pull the connector out that it's attached to. Right, so we're trying to be careful in here, but we'll want to return these back before putting this robot into operation, just to avoid any issues from connectors working themselves loose over time. So we're going to keep going here. They've got a lot of this cloth tape. Luckily, this is probably something you can replace with other cloth tape. The primary thing for these is probably just making sure it's not conductive. Other than that, I don't think the black color has any particular meaning. But yeah, it goes in there. So here are 2 cables going to the front. If we carefully remove these, we'll use the spudger to release the actual retention clip. And these are glued in place, so we're gonna have to be a little careful. We don't want to tug on the cables too much. But if we can get in here carefully and try to pry these out, we'll see if we have success here. Ugh. There we go. All right, there's one.
Success.
So yeah, you can see this glue on the top here. So again, they're doing that to prevent it from shaking out, right, over time. Well, it looks like y'all have been having some fun with this. If we look closely, we can see there's a crack that starts here, goes all the way down over to this side. So this front head nose module going up here to the front definitely had some damage to this plastic. So hopefully when we take this apart, this might be something we can backfill with a little more epoxy. You can see that they've got a lot of open space here, right? So they need to use that much material probably to keep the weight down. But that gives us some options here if we're trying to repair it and keep it a little bit stronger so it doesn't get damaged in the future. All right, so this connector has been giving us a little bit of a hard time. So I'm going to try to go in here between the latch and the outside of the housing with this metal spudger. And I think there's some adhesive that's made it all the way in there. So we're going to try to release that and then see if this will come out a little bit less damaging. Look at that. So that worked. And if we look deep inside here, we can see that adhesive that was on the top side of the latch and preventing it from releasing. So that's actually really good to know. If you need to take these connectors out, you got to release that adhesive first. And I don't even know if we can get the adhesive out of there. We need something even smaller. There we go. So that was the adhesive that was inside that joint. Okay, so we'll flip it over and do that top side then. And get those. Oh my god. Okay, so those 4 screws. All right, so here's the LIDAR module, and we had to open up a couple pieces here so we can try to get the head off. What's really cool about this, so it spins really quick because that's how it's getting the scans. Here's the actual LIDAR portion. We'll do close-ups on that later. But I love how this is a chunky metal cage around this. So really this is just purely for protection. Welded pieces of what looks like steel, really just because that's the first piece to hit the ground anytime the thing falls down or hits its head on anything. That needs to get protected at all costs. Again, this is probably the most expensive single component in the whole robot, or close to that, at least from a sensor's perspective. So trying to keep this happy is really important. It looks black to a visual light, but if you looked at this with infrared light, likely, it's a bandpass material, so you can see through it and see what's inside. But hopefully we'll take that off later and take a look. So for now, we're still trying to get this head and neck region over. We took out this one extra screw here under this leg, and that allows us to release and remove the LIDAR module. It actually comes out to here. Well, once you get it peeled off, there we go. Okay. So we're getting better at this now to get that cleared out, and then it comes out that easy. All right, so we've got the LIDAR unit here. We've taken the 4 screws off of the cage, the protective cage, and now if we open up this collar, it will drop this little spring off the back, and this whole collar should just come right off. So there's one half and there's the other half, and now the cage will come apart. And we've got the cage, the collars, and then here's our LIDAR unit.
LIDAR stands for Light Detection and Ranging, and it does what it says on the tin. Lasers shoot light out and measure the time to receive the reflection. This allows the robot to essentially map the areas around it to detect obstacles. The robot doesn't know what's around it, but it is pre-programmed with the value of the speed of light inside Earth's atmosphere. It has a highly accurate clock to measure time to within fractions of a second, and it has the ability to detect the returning laser beam that the LIDAR shoots out multiple times a second. The computer then does the number crunching to solve the problem it's trying to answer. What objects are around it? In this way, Fido can see an object 3 meters ahead of it. It has no idea what it is, but it knows what shape it is, how far away it is, and whether its internal programming considers it an obstacle or a traversable surface. Now do that hundreds of times a second while spinning the mechanism across a 360-degree arc, and you'll have the LIDAR sensor that you see here. Pretty clever, until you consider that your eyes do essentially the same thing, but in a much smaller package.
Yeah, so this is our LIDAR module. So the primary axis of rotation is this outer one, and there's a motor underneath that's driving that. Then the secondary axis is this unit right here, and this is actually where the there's a mirror here, and then the laser is getting reflected out. So as this inner piece spins really quickly, it's drawing one slice on that axis, and then that slice is also rotating around this vertical axis and giving you a 3D view of the world. Unitree actually calls it 4D LIDAR, which is kind of funny.
Right, so we're done with the LIDAR, and all we're left here pretty much are the legs and the motors inside the legs. So how do you think these legs are put together, and what would we try and disassemble next?
So these legs have three kind of motors in them, it looks like, right? So there's one on this kind of hip joint, one on this leg joint, and then one coming out to the actual lower extremity. So I think we're going to start and try to come from the outside in and start by disconnecting this outer leg first and see if we can get a little bit further inside.
Cool. And that third motor looks pretty interesting. There's not a motor inside this section, so how does that work, do you think?
Right, so I'm really curious to see how they do this. There's a big no pinch warning on the back here of these joints, but my guess is there's kind of a control arm and then some sort of geared mechanism inside here, and then there's probably a motor right here with a high gear reduction to just have that little motion. So I think we'll start here by taking this one apart a little bit more and seeing if we can get into there. All right, so we got those two screws out on this collar, and now we're going to pull this piece out and pop that piece out, and magically these two halves separated real nice. So here we can see this outer motor, and we've got some connectors in here that we're going to need to try to get out as well. It's actually pretty neat. They've got a whole bunch of capacitors just in between the screws there. So there are 5 capacitors and 6 screws, and they're literally alternating a screw with each capacitor. Cute little design there. All right.
Was that just plastic holding these two halves together?
Well, kind of. So if you look at the actual, it's a interlocking tooth mechanism here. So this is a CNC'd surface. You can see the actual machining marks on this surface where they've CNC'd that flat surface to this flat surface. And those teeth all interlock around the outside, and they have these inner pieces to hold it in place. And then this is a collar that's really just holding those two halves together. So all the force that's transferring between this joint is all metal to metal contact, so it's really high strength. These plastic collars are really just holding the two together. So yeah, in theory, if you yanked out on one of these legs, if you pulled one of these legs out really hard, kind of like we've done here, you could probably break one of these, and maybe that's intentional as well. So if there's a high force event, it would actually be a intentionally lower strength failing point that it doesn't cause greater damage. Now, I'd rip these connectors out, but you might be able to salvage the rest of the bot and just replace one leg motor, for example, or one of the leg modules. So let's try to get in here a little bit more. We've got another one of these fun connectors that we've gotten pretty good at this point, trying to get out. All right, so we loosened up the glue around that a little bit, and that comes out really nicely now. You can see they've got a lot of this glue all over just holding these connectors in place. See if we can get that lower one out as well. There we go. And these are keyed connectors, which is nice, so you can't actually mess that up in the future. Yeah, so we've got the male connector here and the female one, so that when you plug them back in the board, you can't get them backwards. There's only one way to connect those. So that's known in industry as poka-yoke, which is something that you cannot mess up at the factory. All right, so we've taken this leg motor off, and if you look deep inside there, you can see the motion of the actual motor. So what I'm doing here is I'm extending and retracting the actual leg, and you can see that that is the motor moving in different directions underneath. So this is only about 90 degrees of motion of the leg, and that's looks like several rotations of the actual motor inside there. So it's a pretty good gear reduction going in. All right, so we're in the main board now. We're going to try to get this removed so we can get the top half of this off. So we're just going to start by removing some more of the tape here. And this is again our positioning module. So in this case, it's using GLONASS according to the connection here. So just make sure this isn't a locking connector, otherwise you can rip that off the board. So it looks like that came off nicely. We'll toss a little piece of tape on there labeled GNSS, because that's what the port is that it was on. This one's labeled MCU, which sounds like microcontroller, but there's probably a Wi-Fi chip is my guess. Cool, so we've labeled the connectors here because these are actually not labeled. So we're gonna toss some markings on here so we try not to mess it up. Again, they've got this adhesive to hold things in place, again for shock and vibe, and these are they have no retention clips on these, so just gently pulling that back and it comes right out. And we can see here there are the 2 power pins and then 2 data pins on those connectors. So make sure we put our label on here as well. And then just keep going down and very carefully pulling these out. Again, silicone on the back as well, just to hold those solder joints in place and limit any damage. And you can see a little bit there where it actually makes it inside the connector. That's probably the intent of that, is to try to prevent those from sliding out. So in the future, if one of the motors does fail or one of the joints does fail, the first thing I would do is take off this outer cover, which again was really easy to access, and just look at those connectors, maybe reseat them and make sure that there was nothing going on there. So that's a good debug trick there that's easy to access. Of course, remove the battery before doing any of that, and just get inside. All right, so that's the 4 motor connections we had here. And then we need to see what more we need to go. So a couple other points here. Try to get these carefully. So that one comes out here. So these are again high power connections. These look like they might be for some of the motors, but it's labeled C-, C+, and C+ as well. So not quite sure. Those might be going out to the first set of motors that are connected to the main chassis, right? Because again, we got the inner motors here, the 4 hips, the 4 intermediate joints, the knee joints, I guess, and then the 4 leg joints that actually go out from there. So we're getting pretty close here. Got a couple more connections to get out. Here's another one. Oh, that's got a B-. Oh, so these are probably the battery connections coming in. The main battery connections there. And then there's a little communications connection, so that's probably also for the battery. Let's see if we can get in there okay. And this one, again, has that adhesive on the side that we want to try to get out. There we go. All right, and we managed not to break this connector, barely. That's definitely difficult to get those out because, again, this little retention clip is being held in by that adhesive that's placed on the board. All right, looks like we have one more fan here we need to remove. So this fan vents out here. So a lot of fans in the unit, but there's also this placeholder for more fans. So it's possible that the Pro and the educational units have even more cooling. Again, they have a higher compute processing units inside, so it's possible that they need more cooling as well to manage that. More fans though means more dust inside, means more power consumption, means bigger battery requirements or shorter run times. So there's always a trade-off with anything we're adding inside. All right, there are 2 more connectors hiding there. These are again RF connectors, and we need to make sure that these get back in the right spot later. So let's label these A and B and then pull it out. There's 1. And there's 2. I'm doing real good, guys. All right, so we've removed all the outer screws and the screws for this connector board, and then the main logic board should just about come right out. And there we go. Beautiful. We've got the main logic board out now, which has kind of opened us up to the remaining of the main chassis, and that revealed these 5 screws here as well. And those look like they're key to the clamshell to holding the upper and bottom, the top and the bottom half of the body together, plus the screws here at the end. So that might give us more access to the inner motors. So I think we'll try that out, yeah. Main chassis screws out. All right, so we got everything on the top half we think disconnected. There are these 6 screws now holding the upper and lower halves together, in addition to the ones that were under the main logic board. So we're going to see if taking these out will release the 2 halves so we can get a closer look at the motors. Those are all out, and if we carefully dump all those screws, 1, 2, 3, 4, 5, 6, hopefully 5, and this is going to be tricky to reverse later. And there we go.
Bit of an understatement. This was a complicated teardown.
Definitely.
Walk us through what you see. What are your thoughts about this machine?
So generally I have to say I'm pretty impressed with kind of how they've done modularity. There's one main logic board that almost everything plugs straight into. They all have accessible connectors. Granted, they're glued down for reliability reasons, so it's a little bit tricky if you haven't done it before. Once we got the hang of it, it was pretty straightforward to start taking things apart. So definitely getting some bonus points there. One of the real challenges, though, is just how much is being packed in such a small space. It's really difficult to get to anything. So I think we're almost at 60 screws just to get to this point, and we haven't even taken apart most of the legs or really gotten inside the motors and some of the cable management assemblies.
No. Each one of these legs looks like it could have another 3 to 4 dozen screws in them individually.
Yep.
And the compactness, the point on compactness that you raised, there are 3 motors on each joint right here within the space of one hand.
Yes.
There's a lot going on here.
There's absolutely a lot going on. But again, something to note is that it's a similar design. Granted, it's mirror image left to right. I'm assuming just what we've seen is that kind of the kitty corner, the opposite end, left front leg versus right back leg, look to be pretty compatible. So there's quite a bit of reusability between the parts, and maybe salvaging parts from different devices as well, or potentially making these available as OEM replacements.
Absolutely. And it also provides us with a window into how labor intensive the construction of these devices must be. We're talking about replacing a single failure point. But when you think about the manual labor that's gone into putting all these components together, that would substantially add to the price tag.
Absolutely. And one of the other things we do want to point out is they have made the lower extremities much more accessible for repairability. They actually included, I think, 4 replacement feet as well. Yeah. So these feet come out with 2 screws and just pop off. So that's a wear point that they provide as a consumable. The other part is we saw it ourselves when we removed that lower leg. It was pretty straightforward with just that collar removal and then 3 connectors inside to get that lower leg out. So if you broke a leg, it's pretty feasible to see that as a repair that could be done by a moderately technically competent person in the field. So that's nice that it seems as though that's designed to be something that could be replaced more easily. It's also something that probably breaks more easily because it's kind of long and skinny and has a lot of high pressure points on it.
Absolutely. These are all the 4 outer motors. Yep. Would be most susceptible to damage, especially as we've seen it fall over multiple times. These are the impact points right here. But the ACE inner motors are a completely different story.
That's where it gets difficult. So really anything from that outer leg in is going to be really difficult to get into. You're talking multiple hours of disassembly and reassembly, hoping that you don't break any of the connections. You probably want to re-glue some of those connectors so they don't fall out after prolonged use afterwards. But, it is possible. So there's something to be said there. Yeah. The other point I will make is all of the, from a complexity perspective, while they're packing a lot in there, from a high level, you've got one main logic board and then 12 motors plugging into it, your sensor modules coming from the head, so the light, the camera, and the LIDAR, and then a battery. And that's pretty much it, right? There's some Wi-Fi chips and that sort of thing that's mostly integrated in that main logic board. But from a overall system architecture perspective, it's actually pretty straightforward. And that's actually a big boon for repairability as well, as it makes it a lot easier to know what's going on. Things are labeled. You have connector interfaces that say what's going there, what's going on. And that makes it a lot easier to figure out when something's broken, how to get in there and actually repair it.
Absolutely. And again, probably for the assembly process in the factory as opposed to our benefit. But it does translate to serviceability at the end of the day, which is a win.
Yeah, and we saw some of those placeholders as well, where for the Pro model and the educational model, there's space in here for some higher compute modules, for some additional fans. So again, some of that modularity that they're putting into that base chassis, it means they only need one mold for this main body piece, and then they can have all these different variants built on top of that. And likely most of the other pieces that we saw today are pretty similar. They're just adding on a couple of extra features and plugging those into that main logic board again.
It's a good design. Really good design, plug and play.
So it's been fun. Let's see if we can get them back together.
So that's the Unitree Go2, an impressive little bot straddling the line between research platform and consumer tech. Some of the design choices surprised us, in a good way. Those modular legs? Smart. You will eventually break one, and Unitree made sure replacements are relatively straightforward. Obtaining the parts you might need for the repair doesn't appear to be as straightforward. There is a contact form on their website, and we reached out to Unitree to see whether we could purchase a spare motor and leg. We'll update our blog post if we receive their response. But there are other choices that raise eyebrows, like burying the LIDAR deep inside the frame or that fragile-looking neck section up front. For a robot that's guaranteed to take a few faceplants, we're not entirely convinced it's built to survive the knocks it's destined to take. Still, for the price, it's hard not to be impressed. The Go2 opens the door to a whole new category of robotics, and once that door's open, there's no closing it. Just maybe don't trust this one to open the door for itself, at least not yet. Thanks again to our friend Marcel Stieber for lending a hand with this teardown.